Today we're going to talk about the standard model, but before we do that I wanted to go over the four fundamental forces or interactions between the particles. The first one we're going to talk about is gravitational. We've talked about gravitational, that is the equation Fg equals g m1 m2 over r squared, and that's just the force between objects that have mass. Remember, that force is always attractive. Next one is the electromagnetic or the electrostatic force. It's also a force we are familiar with, Fe equals k q1 q2 over r squared. The difference with that force is it can be attractive or repulsive. Then we have a strong force, that's the one that's going to hold the neutrons and protons together in the nucleus of an atom. And then we also have a weak force. Now I put this relative strengths on there to give you an idea that strong force is the strongest one, and then it goes electromagnetic, the weak force, and then the weakest one is gravitational. Which is always interesting because we're so familiar with the force due to gravity, or gravitational forces. It's because our masses that we're working with are larger. The range for gravitational is 1 over r squared, the inverse square law. Same with electromagnetic. The strong force is 10 to the negative 15 because it resides in the nucleus, and then the weak force is less than 10 to the negative 18 meters. I ranked the forces from most powerful to the least powerful. Strong is the strongest, electromagnetic, weak, and then gravitational. So now we're going to get into classifications. Now, I'm going to say a lot of words that you haven't heard before, and I am not making them up. They're actually in the review book. These are words for the standard model, so we have a lot of definitions today. I'm just going to run through them quick. You should write them down at your leisure. One of the key things is this nice flow chart from your reference table. It has matter, and then it breaks it down into the hadrons and the leptons, the baryons, the mesons, 3 quarks. A meson is a quark and an antiquark. Very handy to use this for any of the questions. So a lepton is a particle that interacts through the electromagnetic, weak, and gravitational forces, but not the strong nuclear force, because it's not located in the nucleus. So electrons, positrons, and neutrinos are classified as leptons. Then we have hadrons. They're a particle that interacts through strong nuclear as well as the other 3 forces. Protons and neutrons are hadrons. Now we have a baryon. Breaking it down, they're heavier particles made up of 3 quarks. Protons and neutrons are baryons. Mesons are an intermediate mass particle made up of quarks and antiquarks. Classified as guys. So, a proton, you look it up and you find it, that's going to be a big particle, baryon. A neutron is a baryon. An electron is the middle, that's a lepton. A neutrino is a lepton. Okay, this is a silly thing that some people might find helpful to help remember which one's the big, the middle, and the little. See, baryon is B, it's the big particles, and meson, the medium-sized ones, and L for lepton, the little ones. So an antiparticle is the same mass but the opposite charge. Now I put an example down, but I'm not trying to trick you. A proton is 1.67 times 10 to the negative 27 kilograms, and that has a +1 elementary charge. So an antiproton is the same exact mass with a -1 elementary charge. So you notice how it has the same mass, can't have a negative mass. Don't get tricked. A positron is a fancy name for an anti-electron. It's the same mass as an electron, but the opposite charge. And then we have these particles, neutrinos. They're neutral particles that have little, if any, mass, but it does have energy and momentum. Now I have a couple more words. Quark is considered a fundamental particle. It's right now our smallest particle that we have. And an antiquark is the antiparticle of a quark. So the symbol of it is a line over the top of the corresponding quark. So I'll put an example here. So anti-alpha, see how it has the line over the top? So they have the same mass as an alpha with different charge. So now what we're going to do is we're going to find your table in the reference table that has all the different particles on it. It has ups and charms and tops, so find your reference table, pull that out, figure out how to make a particle. The rules for building a particle. It must be integer values, so a -1, a 0, or a 1. The baryon must be made up of 3 quarks and a meson, a quark, and an antiquark. So look at the particle tables in your reference table. We're going to create a baryon that has a charge of +1. So we know from our table that a baryon needs to have 3 quarks or antiquarks. So +1, I used up, up, down. So find in the table the charge for an up. Charge for an up is +2/3 E. Charge for another up is +2/3 E. And down is -1/3. So if we add up those fractions, we're going to get a +1. So that's just one example of what would get us a +1. So now if we create a meson that has a charge of -1, we know a meson is made up of a quark and an antiquark. So -1, I used an anti-charm. So find charm, so it says +2/3. Well, we know an anti is the opposite charge, so it'd be -2/3 plus a down, so a -1/3. Add them up and you get -1. Now you know how to make particles. Have a good day.